Hi 7, here's the solution to your question. So question number 19. Write 2 minus 2 square root of 3i in polar form. Hence, find all values when which 2 minus 2 square root of 3i to the nth power is purely imaginary. So first, let's change this 2 minus 2 square root of 3i into polar form. Then the best way for me to do this, I know you use unicircle, but for me, I prefer to draw on the Argand diagram. So this is 2 comma minus 2 square root of 3. So when you point this on the coordinate plane, then you get this point. So x coordinate 2 and then y coordinate minus 2 square root of 3. And as you already noticed, this is 1 square root of 3 and then 2. 30, 60, 90 triangle. Special triangle. So which means the magnitude of this vector should be 4. And the angle should be 60 degrees or pi over 3. But since you're measuring angle clockwise, this is minus pi over 3 radians. So if you convert this into polar form, you get 4 cis minus pi over 3. And then next, let's move on to the raising power step. So raising power with rectangular form is so inefficient. So we're going to switch that, replace that rectangular form with polar form. So 2 minus 2 square root of 3i to the nth power becomes 4 cis minus pi over 3 to the nth power. When you expand this, you get 4 to the nth power cis minus n pi over 3. But we want to find the value of n, which makes this expression purely imaginary. So when you draw the axis, you get real axis and imaginary axis. And if you want to get purely imaginary number, the angle must be either pi over 2 or 3 pi over 2, or which can be minus pi over 2, and so on. And the difference between these 2 points is pi. So every pi, you'll get purely imaginary number, adding from pi over 2. So in general, if the argument of this expression is pi over 2 plus pi k, where k can be any integer, then this whole expression becomes purely imaginary. So let's set pi over 2 plus pi k is equal to minus n pi over 3. Then since every single term has pi in the numerator, we're going to get rid of this pi to make it more simpler. Then you get minus n over 3 is equal to minus n over 3 is equal to 1/2 plus k. And in order to get rid of the fraction, let's multiply 6 to every single term. Then you get minus 2n is equal to 3 plus 6k. If you divide both sides by minus 2 in order to isolate n, then you get m is equal to minus 3/2 minus 3k. But then again, I mean, you can leave the answer like in this way, or since the only thing that matters is the multiple of k, so you can just convert everything to positive. So this can be rewritten as 3 over 2 plus 3k, because eventually, like, depending on what k is, you're gonna get the same n.